Bismillahirrahmanirrahim. So direction in vector space, we have this UA, which could be UA or UB. W, as I have told you, is additive right Gaussian noise vector. So the variance will now be in terms of matrix. So what will be the maximum likelihood decision rule? This will be given as follows. So first of all, we have to drive the distribution of a normal Gaussian vector, and this could be easily shown as follows. So I have referred to the book of Populus, and in this book you could see that if we have a random variable x1 to xn, and they have these functions which are actually functions of these random variables, and these are the output of these functions. If I want a distribution in terms of the outputs, so that can be given by the joint distribution of the inputs divided by the Jacobian. So, and we know Jacobian is given as follows. So how can we drive this? Uh, this is the same formula from Populus, and these are the outputs, these are the roots. First of all, I find the Jacobian, the derivation of, for example, y1 with respect to u1, y2 they will be all zeros, we get sigma as a power of n. I put these values here. So as all of the joint distribution, all of these inputs are independent, instead we come up with the product of the distributions of each individual noise, product n times, and you can add them up, starting with 1 square, 2 square, up to n square, is will become naught square of w. So that all those w1s, w2s, wn, and I can substitute the value of w now in terms of output. So it will be w minus u divided by sigma square, comes out to be as follows. This goes here, and so sigma square is n naught by 2, so, and hence we have the final derivation. So once this is right, we can go back to our book. So here you can see that after that derivation, you have one distribution with respect to UA, other with respect to UB. So we will be choosing UA if its probability is greater than B. So we can simplify, you can see all the terms cancels, it's minus 1, turn the sign, and just get the sign to as follows, less than this. Now this becomes the nearest neighbor rule. So what will be the probability of error if U is transmitted, but we find that the probability of this term is greater, in other words, y minus ub is less than y minus ua, then in that case you get an error. So you can also say that the error will occur when w, so this is equal to w, y minus ua, and this will be w, because y is equal to 0 plus w, so y minus ua is w, is greater than w plus ua minus ub. Y is equal to w plus ua. So we substitute here y minus ua is w. So if this is greater, in other words, y minus ua is greater than y minus ub, in that case you will get an error. Because according to nearest neighbor rule, this must be smaller. If I take square on both the sides, probability of error will be when this term is greater than this term. So when I solve this, so this you can see here that probability of w mod square being greater than this can be given as follows. First of all, I can open this up as follows. So mod square is actually is equal to the same vector transpose. This will be 1 cross n, this will be n cross 1, will be 1 cross 1, and then the transpose comes here. You can multiply with these brackets, and you will get this term. So w mod square, and all of this term written here, this will become w mod square. This will be written here. W mod square and mod square will cancel, and so this term goes here. This becomes negative. This term remains here. So I multiply throughout the negative. This goes here. This remains here. This you can already see. Same thing. Now, what is the distribution of this term? For distribution of this term, we will use the appendix 8.11, equation 8.11 of the appendix. And